All right. Hey, everyone. Welcome to EECS 494, Winter 21, Discussion number 8. Today, we're going to be talking a little bit about user interface development and a couple different topics related to UI. Why don't we just get started? The first thing I wanted to talk about that's kind of related to user interfaces, and that is text and fonts. So you might have noticed in Unity, if you try and add a canvas UI element like a button or a piece of text, you can choose between text and text mesh pro or button and button text mesh pro. And you might have been wondering, what is the difference between the two of these? So this blog post here, which I'll link, is kind of explains the differences. But long story short, Text Mesh Pro is a replacement for text. It uses a better rendering system. It makes your fonts and text less blurry, especially if your game is going to have multiple different resolutions. It supports like colors and other stuff very well, like HTML tags. It supports shaders. And yeah, overall, it's just a much better system than the built-in Unity text system. So the first thing I wanted to let you know is switch to Text Mesh Pro on your projects. And the way you can do that is, you add in a UI element that says labeled Text Mesh Pro, and then what will happen is in your assets folder, Unity will add this folder called Text Mesh Pro here with all this stuff in it. So it'll add that in, yeah, and then you'll be able to use it just to create your UI elements. So yeah, that's what I wanted to mention in regards to that. Make sure you're using Text Mesh Pro rather than text, because it's going to make your UI elements that much better. It's going to make your game look a lot more professional, and it's going to make things feel a lot less blurry, especially as you pick different resolutions in games. On that note, one thing I wanted to show you is how you can install new fonts and import them using Text Mesh Pro. So let's start off by finding a free to use font that we have. Google Fonts is a great website to find fonts with permissive licenses that you can use in all your projects. I'll be using it to find a font right now. Why don't I pick a display font, something cool looking. Let's see here. Which ones look cool? I like this one. Let's just pick it. So what we're going to do is we're going to find this font, and we're going to say download family, and that's going to give us a zip file. I'll put it in my 494 folder. I show it in the folder, and then I unzip the folder that we downloaded from Google Fonts. And now you'll see there are these .ttf files. I'm just going to copy over the regular .ttf file. So I'm going to click on copy. And then I'm going to go to my Unity folder, if I can find it. And then in my assets fonts, I'll click paste. And that'll add this fonts right there. So now if I come back to Unity, and I look in my fonts folder, you can see Cinzel Decorative has been added as a font asset here. Now the next thing we do is we go to Window, we go to Text Mesh Pro, and we click on Font Asset Creator. and it's going to add this window to the Unity editor, which is your font asset creator. I'm going to find the font in my project folder, and I'm going to drag it in here where it says source font file. I have the Atlas resolution set to 4096. I believe default it'll be set to a smaller resolution. This is just to say how high resolution your font will be. Once you do that, you click Generate Font Atlas, and what it will do is it will create this sort of what's called a font atlas, which is what TextMesh Pro needs for its fonts. So once we do that, I'll hit Save As, and then in my fonts folder, I'll just save this. And it gets created as, you see this little F icon here? That is the TextMesh Pro font symbol for a font asset. So I'll close out this tab. And now if I want to apply this to a TextMesh Pro object, I go to my TextMesh Pro text, and I find the thing in the inspector that's labeled font asset, and I can drag in my new font. And there we go. We are now using a new font. And why don't I go here and replace this font as well? And here we are. Looks kind of weird, doesn't it? Not sure what's going on with the colors here. Why don't we just keep this as the old font just because it looks better? I don't know what the glitch is there. I don't want to really figure that out right now. So that's how you import a font and add it to TextMesh Pro. And yeah, we can go ahead and use these fonts. The next thing I wanted to talk about is review the basics of UI components. So every UI element, so every game object, as we know, has a transform, which is its position and rotation and scale. Every UI element instead has a component called a rect transform, which is the UI version of transform. One of the parts of the rect transform is the anchor and pivot. What the anchor and pivot is essentially, it describes where the 0, 0, 0 coordinate for a UI element is. And the reason this is important is that you want to create UI user interfaces that scale well on different screen sizes. A lot of games, like AAA titles, will have options for different resolutions and different aspect ratios. And if your game supports multiple aspect ratios and resolutions, you're going to want to make sure your user interface looks good in all of those aspect ratios and interfaces, and you don't want to have to hard code everything directly. So the best way to achieve that is to be smart about picking your anchor. The other thing I wanted to mention real quick is your canvas itself. Make sure you set the UI scale mode to scale with screen size. And what that means is when the UI becomes bigger or smaller, it will scale the size of the fonts accordingly. If you were to make this a constant physical size, regardless of the size of the screen, things would remain the same size. And if you had constant pixel size, it would do the same thing. So we're going to keep it at scale with screen size. And by the way, in the game view, I have it set to 16:9 resolution. The other thing, again, like I mentioned, is anchors, picking smart anchors, and why this is important rather than just like keeping it in default and then moving your UI elements to where you want them to be, is because, again, you should try and think about your UI elements as being positioned in one of the 4 quadrants of the user interface or in the center, so that when, again, the size of the screen changes, things move accordingly. A good example, let's take this text and let's place it in the top right corner like this. And see it's right now positioned 0, 0, 0 in the top right corner, or in the top left corner. And when I make the thing bigger and smaller, or if I make it free aspect and I change it and make it bigger or smaller, it stays on screen in the top left corner, scaling accordingly, which is great. On the other hand, let's say we kept this in its default location, default anchor, which is middle center, and then I sort of drag it over using X and Y, and I say, okay, I want it to be in the top corner. Now what happens is if I resize my screen here, it fails to keep it in the right position because it's essentially not anchoring itself to the top left corner. It's anchoring itself to the center and then offsetting it based off of the center location. So not a good thing, not what we want. So again, when you're designing your user interfaces, you want to think about why don't we make this -20? You want to think about making sure you kind of think of your user interface elements as very generally in specific quadrants or parts of the screen, and then using that to decide your anchor, and then positioning off of that to be like based on offset from there. So yeah, I wanted to bring that up. Make sure you are being smart about picking your anchors, from your anchor presets. Yeah, cool. So that's what I wanted to say in terms of that. Now, why don't we go ahead and think about how to make these elements, these UI elements that we add, feel more juicy. The first thing I want to mention is I have it unchecked here, but you should generally just remove the component. When you add a button, by default, it'll have a image added to it. I personally don't really like having the image in here, but you can change what that image is to be something else if you are creating a user interface that looks like a real object or something like that. I'm gonna go ahead and remove that. But what we're gonna kind of make our user interface do to make it feel more dynamic is we're gonna make it more responsive to user input. So we're gonna, when we hover over this button, we're gonna make it a little bit bigger, and then when we stop hovering over it, we're gonna make it the normal size again. So what we're gonna do, I already have made this component. Where did I put it? Grow on hover. So let's go ahead and edit the script. Let's open it up here in our text editor. So the first thing that we want to do is add this import statement using Unity engine.event systems. Event systems is the library for UI events that we want. So the events that we're going to deal with are onPointer enter handler and onPointer exit handler. Hold on, it's yelling at us. iPointer exit handler, sorry. And iPointer exit handler are the ones that we want. And we'll notice when we add them, it'll say we don't implement the interface member onPointer enter. So what we're going to do is we're going to implement these functions. We're going to say public void onPointer enter pointer event data data. And then we're going to copy this and make our onPointer exit function, which will have the same function signature, just be different named. And now that we now that we implement this interface and add these functions, let me show you here. I'll just add a debug.log here. Pointer enter. And then we'll add in our pointer exit print statement here as well. If I go back here and I click play, you can see it prints pointer enter when I hover over the button, and then it'll say pointer exit when I stop hovering over it. So pointer enter, pointer exit. Cool. So that means we're correctly implementing the thing that we want with the events that we want. Sorry. So now the next thing we're gonna do for this button, I've made a couple public things. I made public float growth and public float grow just public float growth, and the rect transform is what we're gonna care about now. This one we'll deal with later. But what we're gonna do is we're gonna when on pointer enter, we're going to do button transform dot local scale is going to be equal to vector 3.1 times growth, which growth will be our float value. How big we want to grow the button when we hover over it. And then button transform dot local scale equals vector 3.1. We're going to set it back to our default scale when we exit. And I'm doing vector 3.1 because, as you can see, the default scale of the button is 111. So let's go ahead and try it out. Cool. You can see here now when we hover over the button, it becomes bigger. And then when we stop hovering over the button, it becomes smaller. And that is great for, if you have a bunch of buttons, the player will really know what button the game knows what button the player is hovering over. And the player kind of gets a really good feel out of that because they know that the game is paying attention to them rather than it just being static and the player not knowing if the button has been pressed yet. So what we can do to make this even more juicy is add some lerping and put it into a coroutine. So why don't we add public I enumerator go to scale, and we're gonna add float start, float end, float duration. Actually, we'll keep out the duration because we'll keep the duration as a public float up here. And then, of course, we'll need our yield return null at the end. And then we'll add float current time while cur time is less than grow duration. We're going to do cur time plus equals time dot delta time and yield return null. And this is, again, this is how you make a loop that will go for the amount of time set by this variable and in a coroutine. So we're going to want this to be our thing. The other thing we're doing is I have a public animation curve here. And rather than doing a direct lerp where we lerp from the start position to the end position, we're going to lerp from the start position to the end position using the animation curve so that we can get more custom juicy curves on it. So what we're going to do is float current position equals cur time out of grow duration. So we're going to find what percentage we've hit between 0 and 1. And then we're going to say button transform dot local scale equals vector 3 dot lerp unclamped on between vector 3 dot 1 times start, vector 3 dot 1 times end, and current position. So what this does is vector 3.1 times start is the starting scale. Vector 3.1 times end is the ending scale. Current position is a value between 0 and 1. So we'll start off by doing it this way, and what it'll do is it'll just linearly interpolate from the start to the end and grow and shrink. So then what we'll do here, rather than this, we'll say start coroutine of go to scale. Start is going to be 1F, and we're going to go to growth, and we're going to do this over like that. And then we'll do the same thing here, and we'll say growth, and we'll say 1F. That means we're going to shrink down. Now let's go ahead, and we've written a lot of code without testing it. Let's check it and see how it looks. That's pretty cool. It's pretty slow though. Why don't we make the grow duration a little bit slower, or a little bit faster, huh? Why don't we make this 0.3? There we are. Look at that. Juicy. It's growing based on when the user is hovering over it. That looks great. But why don't we make it even better by using the growth curve that I was talking about? So hold on, what's the yeah, it's growth curve dot evaluate. So we want to do growth curve dot evaluate of current position. So what this does is growth curve, what it'll show you in the inspector, you give it in an input and it'll output a value. And we're going to use that to essentially take our value between 0 and 1, which is our like percentage of how far we've completed this animation, and then decide what the scale should be based on that. And we're going to pick lerp unclamped here, by the way, because we want to be able to give it a number bigger than 1 and have it go past the value. So we'll go ahead and do that. Are we doing anything else wrong? Nope, this looks good. So let's go ahead. And if we look at this growth curve here, why don't we pick something like this, where it sort of starts off slow and then speeds up. So that gives it a different look. Why don't we try something like this, where it, hold on, let's restart it. That looks pretty good. Oh, no, wait, hold on. We have to change it again. Let's try this. Let's hit play. Oh, that looks nice. How it slows down as it gets closer. Why don't we pick something? Why don't we start with this and then click add key, right click it and click add key, and what it'll do is it'll add more positions for us. So why don't we make it do something like this, where we go past 1 and then we go up and down, and it's going to be a little squiggly. Ooh, that feels pretty good. Why don't we make this a little bit longer and try that again? Oh, I did it while the game was playing. Sorry. We'll do something like that. If we go ahead here, what we've done is we've made this button now feel very bouncy, just by using the animation curve rather than a direct lerp. And that's great. So yeah, in just a few minutes, we've added this coroutine, and we're using the onPointer enter and onPointer exit functions just to make our UI that much more juicy, which is pretty cool. Another component I've already pre-written, it's called change color on click. What this does is it essentially what it does is when the player clicks on a button, it will change the color to make the player know that the game knows the button was clicked. This is another way to make your buttons feel a lot more responsive. Similar to the iPointer enter and iPointer exit handler interfaces, we're using the iPointer down and iPointer up handler interfaces. And we implement onPointer down and onPointer up similarly to onPointer enter and onPointer exit. And what I do here is I just change between a click color and default color on the text. So why don't we go ahead and add that component here, change color on click, and we'll make the click color this. We'll make sure, remember that public colors in Unity will always set the alpha to 0 for some reason, which is kind of annoying. So you want to set the alpha or the transparency to 100 so that it's not going to do that. What I'm going to do is I'm going to make it just a little bit darker using the value slider of HS and V. I'm going to make the value a little bit darker than our default one, and that'll give it a cool effect like it's being hovered, or like it's being clicked. Uh-oh. Oh, we have a null reference, that's why. So we'll give it the text from our TextMesh Pro here. And now we hover, and then when we click, you can see it became dark to sort of indicate to the player that it was the click was detected. Cool. Oh, I've done it backwards. That's why. Hold on. I want this to be the default color. And then I want this to be our darker one. So let's try it again. So we hover, and then when we click, you can see it becomes dark. And then if I hover off and release the click, it changes back to the color. So we get this sort of responsive feeling of it becoming dark when we click on it. And that's just similar to how the hovering informs the player that the game is still listening. That click also is a great thing to have. Yeah, so that's the other thing I wanted to show you is how you could do something like that using the onPointer down and onPointer up events. It's pretty cool, and it makes things feel good. What else did I want to show you guys? I believe that's what I really wanted to go over with you guys this week. Oh yes, wait, there was one more thing I wanted to show you, and that's the to world point. So there's this function here called screen to world point, and then there's a similar function called a world to screen point. And what this will do is it will oh wait, I might be giving you the wrong functions. Hold on. Sorry. UI world coordinate to UI coordinate. It is world to screen point. That's right. Okay, so this function world to screen point and its sister function screen to world point. What it will do is you give it a vector 3, and it will return a vector 3 corresponding to that world. This vector 3 input is a location in your scene, and then the vector 3 that gets output is it's a position on the UI or on your canvas. And the reason this could be good is if you say have a player and you want you have a UI element for the player that's like its health bar or, you know, the player's name. You can take the player's world position, call camera.world to screen point. It'll give you a screen point, which you can then use in your rect transform position to set the position of that game object. So that's a good thing to have. I can actually, yeah. If you have any questions about that, feel free to message me and I can show you a demo. I don't have one prepared real quick, but I did want to mention that as a very useful function to have. But yeah, other than that, let me know if you have any questions about the things I went over in this discussion. Next week, I'll be showing you how to do screen transitions in between scenes. And how you can add your own custom scene transitions. Hopefully, you're excited to see that. But otherwise, keep up the good work, and I will see you guys next week. Have a great weekend.